All right, hello. So I'm home today and yes, I'm in my jams, but we're gonna go do this thing today. So we are working on hyperbolas. I'm gonna show you how to graph them, how to get the standard form of the equation. I've posted the notes online so you can get the blank copy and then fill them in as we go. So here we go. Oh, I also got this really cool contraption to hold my phone, so it'll be a little bit easier, hopefully, moving forward. All right, so the first thing is we are going to be talking about hyperbolas today, and you can kind of fill in the notes as we go. Notice that the graph, I've drawn in a diagonal connecting those two focus points over there, and also notice that the vertices in the center lie on that same line segment, which is called our transverse axis. So kind of similar to our major axis in the ellipse. So fill in the information in the blanks as you go. So it says that the center is the midpoint of the segment that would join your two foci. The foci are C units from the center and the vertices are A units from your center. So notice that those two variables are going to be the exact same as the ellipse that we used. The asymptotes are the lines that the curve approaches. So notice that we're going to have some asymptotes as we draw these in. Now remember, those are invisible lines, so we draw them as dotted, and your function itself or your graph itself is not actually going to be touching those lines. The vertices in the center will always lie on your transverse axis, and it's 2 A units long. The conjugate axis would be the other line segment. And then the transverse axis and conjugate axis intersect at your center. And then the most important part there is, how do you know if something is a hyperbola just based on your equation? We kind of talked about this a little bit when we did our worksheet the other day. So you're going to have opposite signs, one being positive and one being negative when we're talking about our coefficients. All right, so let's go ahead and get in it today. So let me just connect my phone on this stand over here. All right, and we're going to begin with this problem. So the first one that are in your notes on the worksheet that's posted, okay? All right, so looking at that, basically we need to know a couple of different things, right? You have to think, how is it opening? And from this one, we know that it's opening right and left, okay? So that's the first thing you want to think. So opens right and left, because you kind of see those curves over there, okay? These part here are actually asymptotes. They're not drawn in as dotted, but they are. They're not part of your graph. So since it opens right and left, we do know a couple of different things. So you want to look at your, hold on, I'm going to just pull up the table, although you have it on your sheet, but you want to look at the table there, right? So let me put it a little bit closer. And remember, the standard equations are the ones that you do have to know. Notice that your a squared value always comes first in a hyperbola, whereas an ellipse, it did not. It did switch locations depending on where your major axis was. But for a hyperbola, it always comes first, and your b squared value always comes second. The thing that does change is what's above your a squared value. If you have a horizontal transverse axis, notice that your a squared is underneath your x's, which makes sense. X lies horizontally. So that one's going to be opening left and right. Your other one, the a squared value, notice above it is a y. If your y value comes first, noticing that it's going to be opening up and down, which means vertical, right? Kind of makes sense because your y values are vertical. All right, so based off of that, we know it's opening right, left. So if that's the case, opening right, left, that means that our x's are going to be underneath your a squared. So let's just rewrite this, x minus h squared. Notice that also it's a subtraction sign in the center, whereas your ellipse was addition, y minus k squared, and then over b squared is equal to 1. So we want to figure out where the center of this graph is. So if we look here, the very center would be where those two asymptotes intersect. And you notice here it's at 0, 0. Okay, so your center is the origin. So the zeros are what you're going to be placing inside for your h and k values in your numerator. So far we've got x squared over something minus y squared over something. If you want to put the x minus 0 squared or the y minus 0 squared, that's okay. And then that's equal to 1. So we do need to locate our a and b values. So I'm just going to take a marker here just so you can kind of see it in my notes. The a value is going to be the distance from the center to your vertex. So I'm going to label this part as your a, And that means that in the other direction is your b. So from the center up to the top of that box there is going to be your b value. So if we count your A would be 1, 2 boxes. So A is 2 and B is 1, 2, 3, 4. So when you plug that into your actual equation, we know A squared is coming first. So 2 squared is 4 and then 4 squared is 16. And that would be the equation of the very first one. So that was the equation of that first graph. So now I want to start from scratch, right? If I give you an equation, can we go ahead and actually graph the hyperbola? So if you look at the second problem that's on your worksheet, I'm just pulling it up 1 second. All right, here we go. Second problem on your worksheet. What we want to do is we need to get it in the correct form. So in order to get that in the correct form, all right, so that's this one right here, number 2, follow along. Okay, so in order to get this one in the correct form, what you need to do is obviously set this equal to 1. In order to do that, we divide by the 16, just like we did in the ellipse. So nothing new here. When we go ahead and simplify this, we know it becomes x squared over 4, and then we've got y squared over 16, and then that's equal to 1. Okay, so that's in our standard form. Notice we've got a subtraction sign, we have it equal to 1, and then we have to notice what comes first. So in this one, the x value comes first. Well, if the x value comes first, that means that it's going to be horizontal, right? So we've got horizontal, which means it has to be opening along the x direction, which would be right and left. So we have a right-left opening, all right? So we need to figure out, well, what are the other pieces of information? So we need the center. All right, you can hear the baby crying in the background, that's okay. All right, so the center, right? Your center then is connected to your x and connected to your y. Notice that there's nothing attached there in the numerator, so our center is just 0, 0. So we need our focus points and the vertices and all that stuff. So what you want to do is figure out what is A. Okay, and A, remember, comes first is your A squared value, which means that A has to be the square root of that. Well, the square root of 4 is 2. And that means that B is the square root of 16, which is 4. Now that tells us distance. So what I want you to do first is let's go ahead and plot out our center. So the center, remember, is at 0, 0. So I'm just going to place a dot there. Hopefully you can see this. And then from there, we know it's opening to the right and to the left. Well, if it's opening to the right and the left, right, that's our transverse axis, it's horizontal, we are going to count our A value along that axis. So we're going to count A 2 units, right, to the right and to the left. So 2 to the right and then 2 to the left. That means we're going to count our B value, which was 4, up and down. 1, 2, 3, 4. 1, 2, 3, 4. And this is kind of just going to be like a guideline of a box. So it's going to be kind of weird at first. What I want you to do is just kind of connect them with a dotted line. So I'm just going to go along here. So my box is going to be dotted. I'm just dotting it around. So something like that. So now what I want you to do is we are going to connect the diagonals of this box. So just take something straight and once again, dotting it out. So this isn't totally ideal because I'm doing it in a marker just so you can see it better, but hopefully this works. All right, for the next one, I'm just gonna kind of rough it out, but there we go. All right, so we just have like a guideline like that. So these are going to be your asymptotes, the diagonals that you just created. Notice I extended it to the outside of the box as well because my graph is going to actually extend also. So the graph of this hyperbola, this value right here is going to be the vertex. And you're going to swoop it out towards that asymptote, getting really close but not touching. And then the same in this direction. Right? Now noticing it's opening to the left as well, so I'm going to do the same thing on this side. Swooping out close, not touching, and then the same thing over here. So all of this stuff in the center, those dotted pieces are not actually part of the graph. They're just guidelines to help you. So let's get the other pieces of information now. We need the focus points, okay? So in order to get the focus points, notice that the equation is a little different than the ellipse. It's actually c squared is equal to a squared plus b squared this time. Well, your a squared value, notice, remember, was 4, so we're just plugging that in for 4. The b squared is 16, and we got 4 plus 16, which is 20, so c is rad 20, which we do have to simplify. We know that it's 4 times 5, so it's really 2 rad 5. So 2 rad 5 is the actual distance, and you're always counting from the center. And notice it's right left, so we're going to be going towards the right and to the left. So we need to figure approximately how many boxes that is. So rad 20 is in between rad 16 and rad 25, so it's 4 and a little bit. All right, so let's graph that out, 4 and a little bit. So from the center, we're going to go to the right, 4 and a little bit. 1, 2, 3, 4 and a little bit. And then left, 1, 2. Wait, I can't even see that. 1, 2, 3, 4 and a little bit. I think that's about it. I don't know. Okay, so that's it for the graph. But we just need to actually find the information now. So the focus points, remember, we went to the right and to the left, always base it off the center. That would be an x change. So I went to the right 2 rad 5. So that's a positive 2 rad 5. Notice the y value stays the same of 0. And then I went to the left 2 rad 5. Y value stays the same, so it's negative 2 rad 5, comma 0. So then I need my vertices. So the vertices were these values here, right? So we can get that very easily. That was just your a value. Your a value was 2. It's an x change. So I was at 0. I went to the right 2. I went to the left 2. The last part is the equation of the asymptote, and this is probably the most challenging for people to understand. So for this one, it's kind of easy because we already know from geometry, we know where it crosses the y-axis. We also can count the slope, but that's because it intersects at the corner of our box very easily. That's not always the case. So I do want to show you another way to find it. So give me 1 second. I'm just going to clean off this other board. So what I want you to remember is your point slope formula, which is y minus y1 is equal to m, and then x minus x1, okay? Now, from that, the x1 and the y1 are going to be the center, because notice both of your asymptotes go right through the center. So the center here is 0, 0, so that's kind of nice. The other part is the m value, which is your slope. Now, obviously, we can count it here, but how would you find it if you can't? So we think about slope. Slope is the change in y over the change in x. So notice from the actual original equation, we do have some x and y values. So what I do is I look for the number that's underneath the y squared. And I'm going to take the square root of that. So whatever your b value is actually going to be your y change. Because if you think about it, you counted up 4. So that's going to be my y change. And then what's underneath your x squared value, but remember the square root of it, your a value in reality, how many you counted right and left, is going to be your x change. So we counted to the right or to the left 2. 4 divided by 2 is 2, so 2 is going to be your slope for this problem. So when we plug that in, we've got y minus 0 is equal to 2, x minus 0, right? So we know that we can obviously simplify that up. We've got y is equal to 2x, but that's not actually good enough because you notice here that you have 2 asymptotes. Well, if I have 2 asymptotes, notice that they're actually going through the same point and the slope is exactly the same, just one's positive and one is negative. So all you need to do is just add in that plus and minus for your slope in there. So we've got for the equation here, y is equal to plus or minus and then 2x. All right, so that's the first from scratch. So notice we'll move to problem number 3 now. So if you can go ahead and jot that down, what I want you to do is complete the square, obviously on your own. So if you need to pause the video, go ahead and do that. You should be able to get it into standard form on your own at this point because we've been doing this for every single type of conic so far. I'm gonna go ahead and do it on my own over here in the meantime. All right, so let me just rewrite it. Did I even copy that right? x squared plus 8x plus 16 is 0. All right, so you're completing the square on your own. I don't recommend changing the order of the variables. Just know that your x's are together and your y's are together. That's all that I care about. So yes, of course, the y squared comes first here. That's fine, leave it, right? Because in a hyperbola, it doesn't matter. Y can come first or x can come first. So I'm just going to quickly do that. I notice that I can't complete the square with the y, so I'm just going to rewrite it. But with the x, I'm going to pull out the 4. Completing the square with the 2, we know it's plus 1, and I subtract 1 in the same inside. And I got minus 16. Factoring that out, negative 3y squared plus 4 times x plus 1 squared. Don't forget to distribute. 4 times negative 1 is negative 4. Now, notice from here, you do have to go ahead and move the constant over. So you're going to add the 4 to the right-hand side. And then notice we have it equal to negative 12, but we have to have it equal to 1. So we're going to divide out the negative 12 on everything. And that'll kind of help us with the negative signs there. Notice that a negative divided by negative is a positive value. So we have y squared over 4. Positive divided by negative is a negative. So we would have that minus sign, x plus 1 squared over 3. And then that's equal to 1. So this is going to be the standard form. All right, so there's our standard form. Now, from that, we can get a couple of different things. Remember, we can get the center. So the center, if we go ahead and fill it in, remember it's inside, opposite side. So inside attached to the x value is plus 1. We know it's the opposite sign, which is minus 1. So I'm just going to add that in over here. So we've got negative 1, and attached to the y is nothing. So negative 1 comma 0. All right, so we want the focus points, and in order to get that, we need to have some a, b, c values, right? So we get c squared, we do it over here, c squared is equal to a squared plus b squared. Now, remember the a squared value always comes first, so in this case it is 4, the b squared is 3. So we've got 4 plus 3, which is our c squared, so c is rad 7. When we're graphing it, just get approximate number of boxes. So it's in between the square root of 4 and the square root of 9. So we know it's 2 and change. We also need to know what the direction of opening is here. So notice that the y comes first. Well, if the y comes first, that means it's opening up and down because it's a vertical transverse axis. All right, so let's go ahead and get to the graph. So the first thing is plot your center. The center's at negative 1, comma 0. We know that we are going up, down. So we're going to count up and down our a value, right? So the a value, remember taking the square root. So the square root of 4, a is 2. So we're counting up 2 and down 2. We need our b value, right? So the b value, remember, is taking the square root. So here we have, it's the square root of 3. Well, we need approximate number of boxes so that we could graph it. So we know that it's less than the square root of 4, which is 2. So it's 1 and, change. So 1 box and a little bit to the right. And then 1 box and a little bit to the left. So it's a little tiny box here, and that's okay. So remember, connect them using dotted, and we're going to make it a box. And this is why the asymptote, it'll be a little difficult because notice it's not intersecting on the corner of the box, and that's okay. We're going to use something straight to connect the corners. And remember, extend in either direction. Something like that, right? Nothing crazy. I mean, this is a rough sketch, right? It's obviously not exact, and clearly it was off a little bit, but that's okay. And then just remember that this one is opening up, down. So if it's opening up, down, the vertex is located here this time, and here, not on these ends right here. So we're gonna swoop it up, getting close to that asymptote over there, and the same thing on the right, and then on the bottom doing the same thing. So something like that. It's not really curvy, but you get the idea. So we need the focus points. So, well, let's get the equation of the vertices first, since we already kind of did that. So from the center, we went up to get the vertex, right? So if we went up, that's going to be a y change. So notice your x's are staying the same. So I'm just going to rewrite them as -1 comma something, just so I have that in as guideline. So I was at 0. I went up. How much did we go up? We went up 2 boxes. So 0 plus 2, and then 0 minus 2. So those are the coordinates of my vertices. And now I'm going to go ahead and figure out the focus. So the focus, remember, we went, let's see, our C value here was rad 7. So we went rad 7 up and rad 7 down, which we didn't actually graph. So let's do that. About 2 boxes and a little bit up, and 2 boxes and a little bit down. So it's very close for this one, just because it's a little tiny, and that's okay. So once again, your x values did not change, but the y's did. I was at 0. I went up rad 7, so rad 7. I was at 0. I went down rad 7, so negative rad 7. The last part that we have to do is find the equation of the asymptotes, and we can't obviously count here because we do have some radical values, so we do need to solve for it. So we remember our point slope formula. Y minus y1 equals slope times x minus x1. So we do have our center. Remember, the center was -1, 0. And now we need our slope. So that's change in y over change in x. So we always look at the components from the equation. The y value comes first this time, but remember, it's always the square root of that. The distance, which was 2. So 2 is on top. And underneath x, we have 3, but remember, always the square root of it because it's the distance, and the distance was rad 3. So we have 2 over rad 3, but if you remember from our radical section, you're not allowed to have that as an answer because you're not allowed to have a radical in the denominator. So we do have to go ahead and rationalize. So we're going to multiply by rad 3 over rad 3, and multiplying straight across, we have 2 rad 3 over 3. So let's go ahead and just plug into that point slope formula. It's y minus 0 is equal to the slope, 2 rad 3 over 3 times, and then x plus 1. Remember, opposite sign when you're plugging in. The only thing you do need to remember is that obviously it is plus or minus because there are 2 asymptotes. One is positive and one is negative. And you can leave like this or get rid of the 0, up to you completely. So I'm just going to plug that in to the notes. So y is equal to plus or minus 2 rad 3 over 3 times x plus 1. There we go. And there's only one more question left, so if you can go ahead and get started putting that into your notes. You can see that there. Put that into your notes while I clean off the boards. So make sure you're completing the square for that. So I'll just run through that quickly, and then we'll do the graph together. So remember, I would not recommend changing the order. Just make sure your x's together and your y's are together. Don't actually like make x first or y first. Whatever comes first, just leave it. All right. 9x squared. 4x minus y squared plus 10y. I'm going to move over that 55. This way I don't have to really deal with it right now. All right, here we go. So from here, what you want to do, remember, is make sure you take out the leading coefficient for each of them. So I'm going to pull out the 9, x squared plus 6x. You're completing the square root of the 6, so it's plus 9 and minus 9. In front of the y, you notice that there's a negative sign. It's not a positive number, so you still can't complete the square. You have to pull the negative. So -1 times y squared. Notice the sign is changing when you pull it out of the 10y, so minus 10y. We've got plus 25 minus 25, and then that's equal to negative 55. Sorry, can't see it. All right, so what we're going to do is going to come back to the x's. We are going to make this smaller by factoring it out. 9 times x plus 3 squared. Don't forget to distribute. 9 times negative 9 is negative 81. For the y's, bringing down that negative 1, y minus 5 squared. Don't forget to distribute that negative 1 times that negative 25 there, which becomes a positive 25. We do have to add the constants over, so we're adding the 81 and actually subtracting the 25. Remember, it's opposite sign. So minus 25 plus 81. 9 times x plus 3 squared minus 1 times y minus 5 squared is equal to 1. So what's interesting about this is it's already equal to 1. And in every question we've done in the past, it was not, so we had to divide it out. Now, if I divide by 1, it's not really going to change much. So I want to think about this a little differently. I already have the subtraction sign that I need in the center. I already have it equal to 1. Multiplying by 9 is the same thing as dividing by what number? And that would actually be 1/9. So 9 times, oh, sorry. Why am I writing 9 times? I don't know. X plus 3 squared over, remember, multiplying by 9 is the same thing as dividing by 1/9. So 1/9, and then minus 1 times y minus 5 squared is equal to 1. Now notice they both have to be underneath or over something. You have to have a denominator, and the denominator there is just 1. So even though this is a complex fraction and we don't like the way it looks, it's easiest to just write it like this so that we can figure out our a and our b values so that we can graph. So remember, the a squared value does come first, so we do need a, right? So a is taking the square root. A is 1/3. And b is 1. We can get our center. So the center here is inside opposite sign. So we've got -3 and a +5. All right, we need to figure out our direction of opening. Notice x comes first, right? So x is underneath your a. So that means it's going to be a horizontal transverse. So that means it's going to be opening left and right. Left, right. Okay, so with that, let's put some stuff onto our graph that we know so far. Let's move all this back. Okay, so the first thing I want to do is I'm going to plot out my center, and my center's at -3, 5. So 1, 2, 3, 1, 2, 3, 4, 5. There you go. And remember, we're counting left, right, our a value, and the a value is 1/3. So this one's going to be kind of small, and with my marker, it's not really going to help as much, and that's okay. And then I'm going to count up and down 1 box, our b value. So a really, really, really tiny box here. And in reality, I can make the scale different so it looks a little bigger, but it's okay for now. There we go. So now remember, you do want to go ahead and take something straight, connect the corner of your boxes. I'm going to kind of do it freehand just to kind of not waste extra time. Beautiful, something like that. We know that it is opening left, right, so I'm just going to go ahead and sketch that in. So from here, opening and down, here, swoop it. All right, so something like that, just to kind of have a guideline as to what this is looking at. Like the center we had already said was -3, 5, so I'm just going to put that in. And we do need the focus points. So the focus points, remember, we get from the equation. So I'm just going to do that over here. Oops, that's the wrong marker. So you've got c squared is equal to a squared plus b squared. The a squared value here is 1/9. The b squared value is 1. So it's 1/9 plus 1, which you know is 1 and 1/9. But we can rewrite that. We know that 9, remember, you multiply and then you add. 9 times 1 is 9, plus 1 is 10, so you really have 10/9 is equal to c squared. Now we need c by itself, so we're going to take the square root, and we can take the square root of this very easily. We know that 9 is a perfect square, so you have c is equal to rad 10 over 3. So not too bad. All right. So we know that that's going to be located inside of this focus over there, and we can get the approximate number of boxes to graph that out. But I'm just going to keep moving with the equation. or the coordinate rather. So if I want the coordinate, we know we're going to the right and to the left. We started out at the center, right? And we went to the right. So if we go to the right, think about what's changing. That's an x change. So we were at -3. We went to the right, rad 10 over 3. So -3 plus rad 10 over 3, comma 5. The same thing in the opposite direction. So we were at -3, and then we went to the left, rad 10 over 3, and then comma 5. All right, cool. As far as our vertices, think about how you're moving. You were at -3, and then you went to the right. But how much to the right did you go? You went 1/3. So -3 plus 1/3, right, is really -2 and 2/3, comma 5. The y stays the same. I was at -3 and went to the left, 1/3, so -3 and 1/3, comma 5. The last piece that we're missing here is the equation of the asymptote. So we want to once again think about your point slope formula. So we've got y minus y1 is equal to m, x minus x1. And we know our center. The center was -3, 5. And then the slope we have to find. So we've got change in y over change in x. And remember, it's always the y component, the x component. So we know from the equation here, underneath your y, because y comes first, right? Underneath your y here is 1. The square root of 1 is 1. The distance was 1. Underneath your x's from here was 1/9, but it was the square root of it because it's the distance, and that's 1/3. So 1 over 1/3. Now, obviously, we know we have to keep change flip. 1 times 3 over 1, which is just 3. So m, the slope, is equal to 3. So let's plug in what we know. Y, opposite sign, plus 5. I'm sorry, minus 5. Boop. Minus 5 is equal to the slope, which was 3, and then times x plus 3. Remember, there are 2 equations, so plus or minus, plus or minus. Now, obviously, when I get the equation, I prefer it as a y equals, so I'm just going to add the 5 over. Do you absolutely have to? No. But a lot of times, you'll see it with just y equals. So 5 plus or minus 3 times x plus 3. No, I'm not going to make you distribute it out. Sometimes in a multiple choice question, you will see it in a different form, and then you would have to distribute it out, but this would be totally fine for like a part 2 on a test. So I'm just going to go ahead and plug that on here. So y equals 5 plus or minus 3 times x plus 3. And that's it. So that's everything with your hyperbola. So I'm going to post this up. Please go through everything. If you have any questions, I'm going to let you know when my office hours are going to be later on, and I'll make myself available. Thanks.